Если я скажу, то меня будет слышно или как? Или не будет меня слышно? Вот сейчас тест будет, и сейчас посмотрим. Интересно еще... Если я скажу, то меня будет слышно или как? Или не будет меня слышно? Вот сейчас тест будет, и сейчас посмотрим. Интересно еще... Или не будет меня слышно? Вот сейчас тест будет, и сейчас посмотрим. Okay, let's go. Seems good. Okay, day 6. As your flight approaches the regional airport, where you will switch to a much larger plane, custom declaration forms are distributed to the passenger. What this link is? Okay, that makes sense. The form asks a series of 26 yes or no questions marked as A through Z. All you need to do is identify the questions for which anyone in your group answers yes. Since your group is just you, this doesn't take very long. Makes sense. However, the person sitting next to you seems to be experiencing a language barrier and asks if you can help. For each of the people of their group, you write down the question for which the answer yes, one per line. For example, ABCX, ABCZ. In this group, there are 6 questions to which anyone answered yes, A, B, C, X, and Y, and Z. Duplicate answers to the same question don't count extra. Each question counts at most once. So 6 questions to which anyone answered yes. A, B, C. What the lines mean? Okay. With the answer yes, one per line. Oh, A, B, C. 6 questions to which anyone answered yes. A, B, C, X, Y. Another group asks for your help, then another, and eventually you've collected answers from every group in the plane. Your puzzle input. Each group answers are separated by blank light, and within each group, each person answers on a single line. For example, ABC, ABC, ABAC, yeah, makes sense. The first group who answered yes to 3 questions ABC, yeah. The second group contains 3 people. Combine the answer yes, makes sense. The third group contains 2 people. Combine the answer yes to 3 questions A, B, C. The answer yes only in 1 question A. Okay, makes sense. The last group contains 1 person who answered yes to only B. Cool. For each group, count the number of questions to which anyone answered yes. What is the sum of those counts? Okay, easy. Okay, I will copy the template from the previous round, where I get... Wait. Oh, yeah. Run directory cd6, main HS, and here we have... Oh, actually it MOOCs. I need to attach no session. Okay, we create one. We copy the template from the previous, not the template, but just a few initial lines to read and put file from the command line. Okay, we read as an argument the first argument of the command, and we This argument is a file name which we read. Okay, let's also start interpreter. Okay, also let's do example. Our example, we actually have two. Let's say we have only this one. Cool. Wait, is it supposed to will be one blank like? Why is it two? I know it's one. Okay, cool. So that's easy. We need to do. We want to split not only by lines but also by the blank lines. This was in the previous exercise and I've used split package, but I also want to try to use group by to see if I can do this, because group by allows you to group elements, so you can do the trick with group by like that. Group by A, B, B doesn't equal space, for example, and you can given a string, something yeah, like that. Yeah, you need to import data list group by. And yeah, that way we grouped by split by the space. We also maybe can improve if we do like that. Improve in the sense oh no, it's actually it didn't work. Yeah, that's strange. AB or BA shouldn't matter. Huh, interesting. Oh. Okay, that's by well. A better way is to use split on, which is in data list as well, which is in split package. Wait, or is it data list split? Oh yeah, split on. Yeah, this one. Okay, we also can use parser combinators, which is quite good in the sense that we don't need to wait to entire input, but we split on, we also don't need to wait. So yeah, let's yes, let's use split on slash n slash f, because we have two blank lines, new line and another one, and we apply this to the IO, so we use fmap operator. Okay, and for each of the splits we should we should split by lines, right? Yeah, which function lines can do. And the string is in itself oh, actually lines do quite quite tricky stuff with slash n's, because oh no, actually fine, lines delete /n, so that should be fine. Okay, we will have a list of strings, and strings a list of characters, so that's exactly what we need. So it's answers, right? That's answers. Okay, done. So what we need to do to count? Okay, let's count basically unique elements in the each. Actually, we don't need to split by lines at all. We just need to split by /n and count unique. Yeah, which is okay. Let's say probably we will need it for the star, so let's leave it at that. But what we will do here, we will concat answers. Oh, we need inner concat, so we need to map. Yeah, for each group we need concat aside. So what we are doing is map concat answers, and for each we do a set basically. Yeah, nothing really going on here. Yeah, we want qualified, so our functions won't conflict with the prelude ones. We will have set, and we just need a size of this set. Yes, and we need some of that, and we just print. Okay, too easy, too easy. Oh, nothing really. Data split on import, data list split on. Cool. Example 11, and here we have 11. I think we are ready. Okay, I hope we didn't copy it twice. Okay, that's good. We have task, so we just write main task in, and result is here. Yeah, we got it. So probably the real task starts now. As you finish the last group's custom declaration, you notice that you misread one word in the instruction. You don't need to identify the questions to which anyone answered yes. You need to identify the questions to which everyone answered yes. Ah, everyone answered yes. Okay. Using the same example, yeah, and we need splitting by lines for that. Yeah, basically it's the same, just calculation different. So, okay, let's copy main to star. So star, what we'll do here? So we won't use sets, right? What we will need to use? Or rather, we will use sets. We will create set for each of the line and find the intersection of sets. That's super easy. So we don't use concat. What we use, we still want to do map. Map as from list, right? But also we want yeah, actually that's everything. We want map as from list, and we want combine them by intersecting them. Let's check. I believe data set intersection is in our function. Yeah, it's so what we will do is just fold L intersection, fold L1 even, fold L1 intersection on this map. Yeah. Yeah, this should work perfectly. Yeah, makes sense. Do we need to map? Yes, we need to map. Do we need to sum? Yes, we need to sum and print. Okay, let's do it. L star star. Yeah, that's right. S intersection. Yeah, we need to determine size. Yeah, that's right. Yeah, we need to use example for 6. Wait, that's super easy. Yeah, 6, okay. 3, 6 to 8. It was super easy. Yeah, let's push this. Git add and git commit solve 6th day, day 6, and doesn't matter. Let's go to GitHub. Seems like it's relaxation tasks. Or maybe the trick was to use sets, and if people didn't know sets, they will not use it. But yeah, with sets it's super easy. What else we will do? Okay, let's do another one. The 6th one is really fast. Okay, let's update the name of the stream since we are doing then the day 7. You land at the regional airport in time for your next flight. In fact, it looks like you'll even have time to grab some food. All flights are currently delayed due to issues in luggage processing. Due to recent aviation regulation, many rules, your puzzle input, are being enforced about bags and their contents. Bags are only color-coded and must contain specific quantities of other color-coded bags. Interesting. Apparently, nobody responsible for these regulations consider how long they would take to enforce. For example, consider the following rules. Light red bags contain one bright white bag, two muted yellow bags. Okay, what is muted yellow? Isn't muted is without sound? Muted yellow. Oh, okay, it's some sort of color. Dark orange bag contains three bright white. Okay, dotted black. Okay, basically we have rules about colors. And finally something ends with no other bags, which is this rule specifies the required contents for 9 bag types. In this example, every faded blue bag is empty, every vibrant plume bag contains 11 bags, 5 and so on. You have shiny gold bag. Cool. If you wanted to carry it in at least one other bag, how many different bag colors would be valid for this outermost bag? In other words, how many colors can eventually contain at least one shiny gold bag? If you want to carry it in at least one other bag, how many different bag colors would be valid for the outermost bag? How many colors can eventually contain at least one shiny gold? Let's give an example, hard to understand. With the above rules, the following option would be available. A bright white bag, shiny gold bag directly. Oh, because gold bag is in the description. Okay, so we need not only to find which children, but we need to find outer bags. Or muted, you can hold shiny gold bag directly plus some other bags. A dark orange which can contain bright white, right, which will contain shiny gold. So in this example, the number of bag colors that can eventually contain at least one shiny gold bag is 4. Okay, so we get number of colors that can contain gold. Okay. So basically it's a graph, and also it may be cycled, which is interesting. Do we have or like dark olive bag have two vibrant or no? Seems like rules is no. Okay, so back there is no or, but we have and. Yeah, like 5 fade blue bags and 6 dotted. Let's check input. Like, let's really check if there are cycles there. Yeah, let's create a folder. Yeah, we definitely want to use it here parser combinators to not to read colors and the other junk that we don't need. Well, let's decide how to. Should we just, yeah, let's download input. Yeah, because it's easily, like, that's a constraint. Whether we have cycles or not, it can simplify the task, so. Or not. Actually, not really. Let's, for example, this cycle. Yeah, actually, it doesn't really simplify. Yeah, so the algorithm is that way. We draw a graph because it's not necessarily a tree, right? Directed graph because it's important what contains what. And we find the vertex responsible for gold shiny bag, and we find parents, and then we find parents of parents, and so on. Oh, by the way, it doesn't matter, the amount, it doesn't matter, right? Yeah, at least one, so numbers doesn't matter. So yeah, we find parents, and if the parent of parent is already processed, we know that they can be, we just stop. Yeah, so doesn't matter whether the graph is cyclic or whether it's a DAG or whether it's a tree. Yeah, it's DAG because probably you have vertices with two parents. Okay. So that's really hard, but so let's start our types. Yeah, let's have a rule. And rule is yeah, let's have like bag or color. So we have one color which contains color and int, and we can do it as map because we want to iterate. We can iterate, but yeah, map seems reasonable. strict as M. Qualified, okay. Color to int. Okay. So that's one rule. No? Rule has color of the parent bug and children with colors and number of bags. Number doesn't matter right now, but probably will matter in star. Yeah, what we need to do is to have instance of read for rule. And we want to redefine red preg. We want to have lift, lift which is lifting from text parsec combinators red preg precedent, and we want to lift from. Actually, let's check it out. Low? Oh, I got it. Okay. Okay. Parser combinators. Yeah. Lifting from read pair to read precedent, because we don't care about precedent here, and read pair works very fine. What else we need? Yeah, sorry, basically it's a do. Let's see our syntax. So syntax is a primary color, right? So primary, we are reading. Yeah, so does every color has two words? Let's assume it does. Okay, what else we can do is to read string. But then, actually, what does the string does? Let's see. Text parser combinators repair, right? And we have string. So the question is, of course, gather. Transform a parser does the same, but no, string. Specified string, which is definitely not what we want. What we want is to read string until something. Until bags contain, and yeah, that's what we want. We don't want to assume the color. Just let's assume we don't want to assume. Okay, so nevertheless, what we going to say here is this: bags contain yes, this string. So question is, how do we read here? Probably. Oh, right. So combinations. What if it will read string backs contain, it will read the first one and will stop only on the second one. Then we will have like the first line and then dark orange contained in primary, which something that we don't want. And that's an interesting question. How do we prevent, how do we say that our parser should be greedy? Like the second string should be the one. Don't even know. With this parser combination. So we can write our own parser combinator. I believe standard library doesn't have it, right? Oh, and by, right. And by is one. Yeah, so I see two choices: and by and many till. Let's see what's the difference. Not in scope, really. Yeah, I read by and by. Okay, so what we are going to do is to convert read pair to s, read pair to s and by, and we will read word and by. We need to parser and okay. So yeah, parser will be char space, and words, word 1, word 2. Word 2 space. Let's say 3 words. And how will it work? Separator. Oh, okay. Separator should be after. No. Okay. Okay. So what we need to do here is many satisfy all. Yeah. Okay, so what I think here you should do, yeah, seems like it. So many satisfy construct, I think like that. And yeah, and the second was the char space. Okay, it didn't work. Why? Yeah, let's use types. Many satisfy construct. That's fine. Repeat char. Perfect. Char space. Repeat char. Okay, and by. Okay, and by separation. Oh, okay, and by. So yeah, right. I can just use char, right? I don't need penny. Makes sense. Hmm. Okay, read P to S is applied to 4 arguments, but its type repeat. That's indeed strange. Why does wait read P to S? So and read S. Oh right, and by right. Okay, makes sense. Makes sense. Yeah, because and by arguments. Cool. So nothing is parsed. Word 1, word 2, word 3. How so? Separate, yeah, certified const true, which is yeah, definitely something is broken here. Oh, okay, separated and ended. Okay, I see. So yeah, many two. Many two is only our chance, right? Yeah, many two works perfectly, and it has a single combination, which is the most important part. So what we're doing, we're using many two. Here we say any. Yeah, basically A, and we can use anything. So many till la 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 satisfy comes true because we want any character to be plugged in, but we want them to be ended. Yeah, that's actually embarrassing. So what's the difference between them? I think difference is when you will try to use many till. So many till produces one result. What? What if we use not many till, just many on satisfy const true, and we use character like that? What will happen? we have, yes, so we have two combinations, which is something that I don't want. So many till, wow. Interesting. Okay, so we want to use many till, even though, yeah, string box contain could be written, we want to use it. So we have only one combinations because many till implemented this way. Yeah, makes sense. So we read primary color. What on our syntax? So next is number. So what we are going to do is to read number. Munch, right? Because munch allows you to specify which characters to munch, and we want to munch is digit. And we also want to read it as int. It will be primary color count. Oh, yeah, what's else in our syntax? Then we have color, right? So what we want to do? Then we want simple character, space. Then we have color. Wow, so we have bag or bags. Okay, so we can just search for bag and then optionally skip s. Optionally, I think it's possible, right? So we have here option: parse p or return x without consuming any input, which is perfect. Wait, or return x. I don't need to return x. Yeah, I don't need to return x. Optional, yeah, optional, yeah, makes sense. So we repeat the trick, like many till. So what we can do is to implement string till, which will take only string and will return read pair. Actually, I want to import it as a qualified pair. Yeah, I don't need pair satisfied pair, yeah, no. So yeah, here we have read pair which reads string. Yeah, makes sense. String till. Okay, so what we want? And yeah, because it's empty. Yeah. That's true, and we have end. Okay, I think it makes sense. Po, 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 po. So now what we can do is to read string till bag. Yeah. Child color. Yeah. But also what we will do is optional, p optional s, which is no, is it optional option? Read pass, so doesn't matter really. Yeah, because it returns just unit, so it doesn't matter string character, it will be discarded. What we need to do is to do many of these. So what we also, yeah, so we basically waiting for dot. So what we're saying, many, use this many till, and we don't want to use just many because it contains combinations. Which will be okay, but yeah, I guess let's go for dot. Also we have options here, right? Because after contain it can be no other brag, but that's fine. For now, let's concentrate on doing many until. So here, what we are reading child, yeah. So yeah, let's do it. Like child, which is p read p, which is string and int, which is right, color in the int. That's better. And so we say count, and we say return color count. Yeah, that sounds good. Yeah, and what else we want to do is many till. Yeah? What we know for sure is that we will have end of line, so we can use this one. Let's assume that some colors have dots, right? And so we don't want to stop at dot. What we want to stop dot end line. If we assume that, then then it will be much hard. No. Yeah, let's not use many till sounds perfect. Many till. So we are reading child till we see string of dot and slash n. Yeah, that's perfect. Yeah, so what we'll get? Many child. What we want to have. we won't rate, yeah. Oh, by the way, this doesn't work as well as you think. So what we want to do is string. Okay. So this will be children, and here we will have one more list, and we'll be returning a rule, primary, and actually just color. Color children and sound. Perfect, really. Let's check. Find mono text for the declining text parse combination red prec. Prets parse. Yeah, it's not parsec. It's just parser. Oh, we're using prelude. Read yeah. Parsec. Maybe using parsec is better, but I decided to stay with prelude. Yeah, so we should space main util should be replaced with p space main util. Okay, something else. Yeah, string, string. Yeah, makes sense. Space string is space string. Same with match. Alright, string till. Okay, we will do this. String till. We will change to just string till. Manage to be munch. Okay, what else we have? String 24 string. Okay, I don't know why. Character yeah, this one. Okay, optional CF. Okay, which is interesting. So we want to have. Okay, let's have an option, right? Main util, it will fail if so what it will think is that no other is a color, because like contain, it won't read number. Cool, that's actually cool. So the reader will fail here. Oh, but it's not. Interesting. So p munches digit will read 0 characters, and the read will try to do it and fail. Okay, so what we will use is not read, we use read precedent. Actually we will use read pair. Do we have read pair for int? Read pair int rather. That's interesting. Read pair, okay. Interesting that read is a class but not others, so that's why we use read here. Ah, so we have read maybe. Okay, so what if it fails? What happens? It's nothing. So we need somehow to. Good question. So if it's nothing, what we want to do is to fail. Be fail, right? A child failed. So basically it's not really. Yeah, so what we want to do is when, which is fine. Okay, let's say like this. Okay, let's use another, yeah. It's just easier. Yeah, read maybe. And we will have count maybe, but here what we'll do is count, because a result operation can be actually fail. So what we will do here is count them, and we say maybe. So maybe. What is maybe? So in case just p fail. In case it's nothing, p fail. P fail just fails. Yeah, nothing more. And the function is return. Yeah, because we want to wrap in case. What's interesting is that it's still no, it's not maybe. Right? Yeah, actually that's pure. That's why you use return, right? Can we don't use maybe, but maybe? I don't think so. Yeah. Oh, what? Like say when is just yeah, but yeah, it doesn't unwrap the value. So yeah, unwrapping the value is the main point. Okay, makes sense. Oh, that makes sense to compiler. P file, yeah, makes sense. Totally makes sense. Read maybe, read maybe, read maybe. No, it's supposed to be. It's just in text. Yeah, here. Read maybe. Uh, this period maybe int maybe period. Wow, interesting. It's actual type. Oh, okay. Yeah, that's strange. In the first, namely count m. So count m is a maybe, right? Right, it's already okay, okay, okay. Makes sense. Hey, just you don't need to unwrap. You just say count them. Maybe prefer, maybe just return. Seems fine to me. Ah, yeah, right. Chair S two. Yeah, picture. Yeah, makes sense. Cool. Okay, what else? So we say it's and there is dot slash n, which is totally fine. So what we need to add now is that children. Children, it might be children, might be no other bags. So what we need is here plus 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 plus. And that's fair, totally fair. But how we will look? Okay. Okay, let's do it. Children P. Totally makes sense. And here we have no children, no children P, which is yeah, P string contain begin contain space. So here no other bags dot slash n. Yeah, makes sense to me. So what we're using here, or plus 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 no children P, but what else we want to do is return empty, yeah, empty array because no children, sure. So it can be, but also kind of why not this? Okay, children P, right? So children P is relative child, so it should read. Doesn't it? It fails. Okay. Seems pretty fine to me. Let's actually check it. So we are reading an example. What we want is to build just rules, just print rules, right? Read. And just put print, yeah, like this. Instance. Ah, deriving because, yeah. Okay, yeah, makes sense. Put m, yeah, because it's map m. 27 children P. Ah, right, because I see. That makes sense. No, the M empty, right? Yeah, makes sense. It doesn't matter really. Yeah, because here is map. Sure. All right, because it's contents. Yeah, let's do this. What we have rules. Yeah, this should be fine. Boom, 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 boom. Boom, 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 boom. Expected type. I was thinking. Why do it? Right. So. And lines. Right. Yeah, that makes sense. Oh, no parts. Which is interesting. Example in. Let's use it. Repair to S. No, actually, let's just read. That's right, because I'm using different buffer. Okay, let's just use another one. 7 GCR. Main. Read. Yeah, exactly. /n. Oh, without /n, right? Because so we can just end of input, right? Yeah, makes sense. Makes sense. Oh, that's interesting. Wait. Strange. Chances actually in certain. Right. Okay. No parse. Okay. So what do we have problems with reading in? String till bugs contain. Let's check string till. String till. Yeah, it's all right. Read P into S, right? Right. Too few, but string till... Right. Because we want... contain. Yeah, right. Okay, light red we have. Light red, cool. And we have children and no children. PB is harder, right? Okay. I'll take a break for one. So our question here is, why it's not parsing? Should be, right? Oh, actually, let's try. We have breakpoints in GC. I need to try that. See debugger, okay. Let's use Quicksilver and first load model. Okay, let's break. Second occasional kiss, break 2. Okay, so we can specify line, which is cool. Cool. We run the program main. Okay, and break stop. And we can list. Okay. For the free variables of the expression which belong. Left. Okay. Let's say. So what we want? 34. Okay. Break 34. Okay. Let's do. Okay. It's stop. So we have types. Probably I need to do force on count 10. Just one, which is perfect, right? One bright white. Okay, that's cool. Let's do a breakpoint then on 37. Yeah. Continue. Yeah, should we use this continue? Yeah. Continue. Read just result. Wait, third round is right, top round. Probably coral. Yeah. Doesn't matter. What you can do is next one. Oh, I see. So it's actually step by step. I don't really know. I need. Imagine. We have color, we have count, right? So what we want? Children. 28. 34. Count them. Just to make sure. Count them nothing. Okay, this comma, right? Because I don't use comma. Right? Why would you use? So it happens that I need commas. Set by, right? Which is fine, I believe. Yeah, I believe. It won't produce many combinations if I use set by, because we have a strong, like we have end of the line. So could it be that? No, it couldn't be because we have bag, which is strong ending. So it's not possible that set by will take more commas than needed. Okay, no children P. Many tilt. Yeah, so many tilt should be sep, but I also okay, and then it fails, right? Just back, okay. Set and by. No, you want to set by, and then specifically, yeah, two characters. Actually, let's do. And from list, oh, it doesn't matter. Yeah, I think it doesn't. Right. So yeah, doing it include space. So after comma we have space, but then we deleted space. So yeah, definitely I need here comma and space. Okay, so in one line, too big, right? So what we'll do here, which is interesting, yeah. Yeah, we can use do notation to do this. Yeah, okay. That's the simplest way. We can use, of course, this applicative operation, but who cares? It's just clear to just return. Okay, that works. Okay, let's try previous reads. Let's just try read, right? We had just read, like a read and yeah, but we also want rule in the end, right? Yeah. Nice, nice. So what we also want then, we want the main example to be. Oh, the final didn't work. Interesting. Vibrant plume. Okay, so what's not working is no other bags, which is makes sense. Okay, no other, yeah, because it's waiting for a new line which won't appear because we deleted it. Yeah, I think it will work. Perfect. What we need to do right now then, so we parse it, parse rules. So what we need is to convert each rule. So we will have reverse, so we can go upstairs. Yeah, totally makes sense. So what we are doing, we are reversing the map and finding parents. And so what we need to do is to have a queue, and we need to say, okay, we're starting with the gold one. We find all the parents, and now all the parents in the queue. Now we go through all new parents, finding, yeah, basically it's DFS, right? Yeah, DFS. So we have a rule. What we'll do is say, basically we don't need maps, right? We only lists. But it's nothing, okay? So yeah, so after reversion we might need to combine, so it doesn't make much sense to take a map. Actually it does. Okay, we don't need map, we need only set for reverse, because we don't care about the number after reversing. And that's why you set, so duplicates won't will be the same in the result set. So in the set what we have set, we have pairs of vertices, right? But also what we want to do is to have a list, right? So we want to, if we have child, what parents do this child have? Basically, we don't need, we just need to mark. So, okay, we want to have set. Okay, and we filter by the first. Okay, so we use pairs, and we have duplicate pairs. So what we will do, we will filter by the first element of pair, and we will put in the set all the second elements, and then that's how we deduplicate. So what we want to know, yeah, we want to reverse. So what we want to reverse rule. So we have rule. Yeah, but since we don't, yeah, we can use intersection if we need. Okay, so what we'll have is it will have a lot of rules, which okay, so rule now will be the opposite, yeah. So we have child as a primary and parents in the map, but we don't need map. So yeah, let's not mess up here and just say pairs as we decided. We have color and we have another color, and that's child-parent relationship. Reverse. Prime. Children. Basically what we need is for every children. So elements, what's our mark? Color int. So we actually don't, we need keys. Keys children, and what we need to do is for everyone. Yeah, easy. Yeah, let's do this one. Primary and color in the seems pretty good. Poo, poo. Next thing what we want to do is so since we have this color pairings, which is what we want to do is to learn we want to do deduplicate. That's what we want to have is a map. That's true actually. We want to have a map. List of maps, right? Basically it's the same map. Yeah, it's the same rules. Only like we don't need int and so what? Oh yeah, we want to use something like intersection. So we don't want to. So what would we have is color. So using child, we want to know all parent colors, which is the set. A set of colors, which are parents. Okay, but here we need something trickier, right? So given we have this list, we want to use by why we want to use group. No, we want to group by the C, which is an interesting idea. Okay, fold-del. So we want fold-del. We want a map which adds to itself. Actually, we kind of want a list. Yeah, what we want to use is map alter. Yeah, that's good. So inside, what we want to do is m alter. Right? We want alter, and this alter what we want to do. We want to do maybe. Right? So it will be +1. But maybe yeah, B first, so it will be 1. It either will be 1 or +1. And that's all, right? But what, yeah, that would be all. The only thing that I also need to key, right? Let see. It will be the first, right? Exactly. You see, we have first, so what we will do, we apply first, then the result will go into the alter. Yeah, but we need no, we don't need, right? So we have C and primary. What does it mean? C and prim. That's the color, right? Oh, because I am reversing one rule. Yeah, let's reverse everything. Actually, I will probably go to sleep. But that's a nice problem. Definitely much harder than the previous one.